So last class I think we stopped with this particular equation called P external is equal to P internal plus or minus dP, depending on the work done by the system or work done on the system. So let us take the first equation, that is W reversible is equal to minus integration of V1 to V2 P internal into dV. So we know by ideal gas equation PV equal to nRT, if it is P internal equal to N by VRT. So if you substitute in the above equation, you will get W reversible is equal to minus Vi minus V final. Either you group to 1 and 2 or you can put I to final. So if you write like that, what will happen? N by V RT. Remember, N is a constant, R is a constant, T is a constant. So you can take it out. So you can draw. You'll get W reversible is equal to minus nRT integration of Vi to Vf and I think we missed out the dV. So dV by V. So when you do the integration, what will happen? W reversible is equal to minus nRT ln V final to Vi. So whenever there is a limit, upper limit minus lower limit. So W reversible is equal to minus nRT ln Vf minus ln Vi. So W reversible is equal to minus nRT into ln V final by Vi, because ln A minus ln B is equal to ln A by B. So if we want the ln to be converted to log, remember this is log base x. So remember that is log base exponential term. Okay, so if you want to convert the exponential term to base 10, you have to write W reversible is equal to minus 2.303 nRT into log V final minus V initial, or we will put it as Vf by Vi. Here the base is 10. Make a note, ma. So if Vf is greater than V initial, that means expansion has taken place. How we can say that? What do you mean by expansion? The final force is greater than the initial. That means the internal pressure is greater than the external pressure. So that's the meaning of this particular concept. So the final volume is greater than initial volume. Now the P internal is greater than the external. That's why what has happened? Expansion. So in this case, the work is equal to negative because work is done by the system. Please make a note of these points, ma. So if Vf is smaller than Vi, what is the meaning? Compression. That means P external is greater than P internal. That means work is equal to positive. That is work done on the system. So similarly, when you take, let us assume this is the system. So there are two possibilities. Either heat can go out or heat can come in, or work is done out or work is going in. So let me say the red color arrow is the heat and the black color arrow is work. So what do you mean by this first arrow? Work done by the system. Work done on the system. What do you mean by the red color Q? Heat added or absorbed by the system. Here heat is liberated by the system. So what will you put in this case? Heat is added means plus Q. Liberated means minus Q. Work is done by the system na, it is going to be minus W. Work is added to the system na, plus W. Please mark this diagram ma, and the above table. These two things are very, very important. Without this, you cannot further study this particular topic. Okay. Write down zeroth law of thermodynamics. So remember, this is the law on which the thermometer works. How do you explain this? Thermometer works on zeroth law of thermodynamics. Very simple. Let me take a body called A. Let me say the temperature is going to be for this. The temperature is going to be 35 degrees centigrade. B is here, C is here. Now what will happen? A is having 35 degrees centigrade. Now I am going to bring B and C, where B is going to be in 10 degrees centigrade and this is going to be in 20 degrees centigrade. So if I allow them to leave for some time, after some time, what will happen? What do you think? what will happen to the temperatures, ma? So they all will attain the room temperature called 25 degrees centigrade. So if you look at the first body A, the temperature has got decreased. For the second B and C, the temperature has got increased. So there is a thermal equilibrium that has been set in amongst them. So what is the word that we use? The three bodies are in Rifan, are you there in the meeting, ma?
I didn't hear. No.
Very easy answer, no, ma? So when A, B, C, all three are going to be in different temperatures, and if you allow them to come in contact with each other, after some time, what will happen? All the three bodies will are in equilibrium. It is called as the thermal equilibrium. Please make a note of the word thermal equilibrium. So thereby you gets the same temperature. Now let us read the definition as in your textbook. If two systems are separately in thermal equilibrium with the third one, then they tend to be in thermal equilibrium within themselves. So if A and B is already in thermal equilibrium with them, when they come in contact with the A, automatically all the three will be in thermal contact, which are in thermal contact will have a thermal equilibrium among all the three. That is what the law is saying, and this is the law used in thermometers. Are you clear now, ma?
Yes, sir.
Okay, very good. If two systems are in thermal equilibrium, with the third one, then they tend to be in thermal equilibrium with themselves. Please make a note, ma. This is the law. Once you are done with copying, let me know. So first law of thermodynamics states that the first law of thermodynamics actually talks about conservation of energy. So it is also called as law of conservation of energy. So as per your textbook, the definition states that there are many definitions. In your book, they have given only one. They say that the total energy of an isolated system remains constant. The total energy of an isolated system remains constant though it may change from one form to another. So it is also says that the energy can neither be created nor be destroyed. If it disappears in one form, it will reappear in another form without any loss. So these are all various definitions given. Okay. Now let us see practically how we are going to arrive at the mathematical expression of first law. So you just have a particular piston pump filled with gas where the internal energy is U1. Now what am I going to do? I'm going to heat it. When I heat, what will happen? The internal energy inside will change. Correct? Am I right or wrong? I'm talking to you. I'm not talking to somebody else. You should answer. Okay? So what happens automatically? There is a increase in the internal energy. So can I say U2? So internal energy is actually U2. Now along with U2, what has been added? Heat has been added. U2 plus Q. Correct? Huh? Because I have added temperature. So heat. Now when the U2 and Q combines together, what will happen? The piston will increase. Correct, Amma?
Yes, sir.
The piston will expand. The gas will expand. Okay?
Okay, sir.
So when the gas expands, what will happen? Work is done by the system or on the system?
On the system.
On the system, correct? So U2 plus Q minus W. Correct? Huh? Now, what is the major idea? What do you understand from this? We all know that when the temperature is more, the work is happening. But I want the temperature, I want it to come back to normal. So if I want to come back it to normal, what should I do? I have to compress it back. Okay. So in that case, what will happen? I am adding the work. So plus W. So if I'm compressing, what will happen? Instead of expanding, it will be compressed. So it will come to the normal state like this. So work is done on the system. Correct, Amma?
Yes, sir.
So we can say that U1 is equal to U2 plus Q plus W. So if I rearrange பண்ணுங்களேன், Q plus W will go on that side, U1 will come on this side. So U2 minus U1 is equal to Q plus W. Therefore delta U is equal to Q plus W. Correct? I think one second, I think I made a mistake. That's U1 illa, U2. Just a moment. U1 plus Q so U1 plus Q. But what will happen? U2 U1. Correct, Amma? So equation at the bar U1 will come this side minus U1 Q plus W. Okay, correct?
Yes.
So that is U2. So U1 plus Q plus W is equal to U2. So U2 is equal to U1 plus Q plus W. So U2 minus U1 is delta U, that is Q plus W. This is how the mathematical expression is derived. Copy ma? So now let us take case number 1. What does this case number talks about? It talks about the isothermal expansion of an ideal gas in a cyclic process. So what is it going to talk about? Isothermal expansion of an ideal gas in what type of process, ma?
Process.
What process?
Cyclic process.
Please make a note of that, ma. Cyclic process. So when I say a cyclic process, what is the meaning? Delta U equal to 0. That is total because it's isothermal first of all. So delta U equal to 0. So how do you write delta U equal to 0? According to the first law of thermodynamics. The first law states delta U is equal to Q plus W. Since delta U is equal to 0, Q is equal to minus W or W is equal to minus Q. Please make a note, ma. There are only two options. So in a cyclic process, if heat is absorbed, work will be done by the system. Please make a note. In a cyclic process, if heat is absorbed by a system, work is done by the system. No, sir. I think work is done on the system. So in a cyclic process, if heat is liberated, it means work is done on the system. This is case number 1. Finished, Amma?
No, sir.
Can I move forward?
Yes, sir.
So case number 2, for an isochoric process. What is isochoric? Iso means same, choric means volume. So there is no change in volume. So delta V is equal to 0. What is the meaning? When I say there is no change in volume, there is no work of expansion. What is the meaning? There is no work of expansion. So delta U is equal to Q plus W. This is according to the first law of thermodynamics. So we know that W is equal to minus P delta V. So this is equation 1 and this is equation 1 and equation 2. Now you substitute equation 2 in 1, we get Rifa, I am going step by step. So copy பண்ணிட்டே வா, விட்டுறாத. Delta U is equal to Q minus P delta V. Correct? We know for an isochoric process. இப்போ தானே படிச்சோம். For an isochoric process, delta V equal to 0. அப்போ what will happen to the equation? Delta U is equal to Q. Please make a note, ma. So the meaning is, for an isochoric process, internal energy is equal to heat absorbed by the system. Is that clear, ma?
Yes.
Copy it down, ma. Finished, Amma?
Yes, sir.
Super. Now let us go for the adiabatic process. We all know what do you mean by the adiabatic process. Let me go to the next page. Yeah. So for an adiabatic process, what is the specialty, ma? There is no exchange of heat, or there is no change in the heat. So there is no exchange of heat. The change in heat will be very less. So we didn't consider that. So according to the first law of thermodynamics, we all know delta U is equal to Q plus W. Since Q is equal to 0, delta U is equal to W. So how do you interpret this? So for an adiabatic process, the change in the internal energy is equal to work done by the system. So we can also go for case number 4. So case number 4 is for isobaric process. So in isobaric process, delta P or dP is equal to 0. Change in pressure is 0. So we all know by equation delta U is equal to Q plus W, or delta U is equal to Q minus P delta V. That is at constant pressure. So what do you understand from this? So in an isobaric process, heat absorbed by the system is used for the PV expansion. Heat absorbed by the system is used for the PV expansion, and the remaining is added to internal energy. Copy this, ma. Copy both the statements and let me know. So this is denoted by the letter H, and it is nothing but the definition for enthalpy is given. Actually, what is enthalpy? First of all, you should know what is enthalpy, right? Enthalpy is nothing but the, write down, heat content of a body. Enthalpy is nothing but the heat content of the body. A body has some amount of heat in it, and that heat content is called as enthalpy. So it is a thermodynamical property which talks about the heat content of a body. Is that clear? So how do you define it? It is the, write down, it is the sum of internal energy and product of pressure and volume of a system. So how do you write this? H is equal to U plus PV. Okay, H is equal to U plus PV. And remember, it is very difficult to calculate H directly. So what we will do in this case, we will take two different systems we will use. So H1 is equal to U1 plus, keeping the pressure constant, I am taking V1. H2 is equal to U2 plus PV2. Since I am keeping the heat constant, that is delta H is always nothing but heat at constant pressure. Similarly, I can also derive by first law, delta U is equal to Q minus P delta V. So if you are going to have a constant pressure, make a note, constant volume, then delta U is equal to QV. So heat at constant volume is internal energy, heat at constant pressure is enthalpy. Please make a note of that first on the left hand side. Now you minus the equation 1 from 2. So this is equation 1, this is equation 2. So equation 2 minus 1. What will you get? Write down. H2 minus H1 is equal to U2 minus U1 plus, take the P common outside, V2 minus V1. So you can write this as delta H is equal to delta U plus P delta V. Please make a note, ma. You know what? The same equation I can write like this. The same equation I can write like this also. What is delta U by law? Delta U is equal to Q minus P delta V. Correct? Substitute that delta H is equal to Q minus P delta V plus P delta V. Correct? Appo minusum plusum get cancelled. So delta H is equal to Q at constant pressure. So this is how the first equation came. Puridama, you can either write like this or that. Everything is same. So now you understood QP is delta H, QV is delta U. First you make a note, ma. There is a very big derivation given in your book. I have made it very simple. Once you are done copying, let me know. So now let us take for an ideal gas. Okay, let us apply the above equation for ideal gas. For an ideal gas, we all know PV equal to nRT. If n equal to 1, we all know PV equal to RT. Is that clear? Now let us take for a gas, there can be two states, right? Initial state, this is final state. So how do you write the equation? We know PV1 equal to N1 RT, PV2 equal to N2 RT. Please make a note, in both the condition pressure and temperature are constant. In both the condition pressure and temperature are constant. Now you substitute these two cofactors in the combine the equation. Very simple. Just combine. Try to combine the equation. What will happen? P V2 minus V1. If you take this as equation number 3, this as equation number 4, 4 minus 3 we are going to see. So P V2 minus V1 is equal to N2 minus N1. Take the RT in common. So P delta V is equal to delta NG RT. What is this G denotes, ma? The G denotes the equation is for gas. So it is a gas equation. Now you apply this to the delta H. We know delta H is equal to delta U plus P delta V. So delta H is equal to delta U minus delta NG RT. Please copy, ma. This is a very, very important concept. So now write down, we will talk about something called standard heat of formation. So which is denoted by the letter delta F H naught, or it is also called as standard heat of reaction. So delta R H naught. So enthalpy of reaction or enthalpy of formation, in place of standard heat you can also replace the word enthalpy. So enthalpy of reaction or enthalpy of formation is what we are going to see. It is nothing but it is the amount of heat exchanged during the formation of a compound from its elements at 298 Kelvin and 1 bar pressure is called a standard heat of formation. So for example, you take iron solid plus sulfur solid gives you iron sulfide solid. So the enthalpy of formation of iron sulfide is minus 100.42 kilojoule per mole. Minus 100.42 kilojoule per mole. Like that, any reaction you take, for example, you take carbon solid plus dihydrogen gas gives you C2H2 acetylene formation. So you have to put 2 carbon. So the enthalpy of reaction, you can either write enthalpy of reaction or formation, both are right. Minus 222.3 kilojoule per mole. So likewise we can write many. This equation is called as, the madri, a equation which has an enthalpy in them is called as thermochemical equation. What do you call these equations, ma? Rifa, what are these equations called, ma? Coach. Properties of thermochemical equation. Remember, in a thermochemical equation, what are all required? Basic requirements. Number 1, reactant and products should be balanced. Number 2, phase or the state of the reactant and product to be mentioned. Number 3, delta H value to be written. The delta H can be of 2 values, ma. Delta H can be negative, delta H can be positive. So what is delta H? Delta H is equal to H2 minus H1. If it is negative, now what is the meaning? H1 is greater than H2. If it is positive, now what is the meaning? H2 is greater than H1.
H2 is greater
Correct,
than
amma? So what will happen? H1 is greater than H2, na? Heat lost. H2 is greater than H1, na? Heat gained. Correct, amma? Can I say like that? Apo, what I can write? Heat lost, na, it is called as exothermic. So for all exothermic reaction, delta H will be negative. What is the meaning of heat gain? Endothermic. For all the 8 gained energies will have positive. So this is one set of concept that you need to know. Second thing, the number of coefficient and the delta H values are fixed. If you change the number of the coefficient, the delta H value will also change. Okay. To give you a clear picture, let me take an example. So half Cl2 gas plus half H2 gas will be equal to HCl gas. So the delta enthalpy of formation is equal to how much ma? Minus 92.4 kilojoule per mole. Illa sir, I am going to multiply the whole equation with 2 and make it as a whole number. Abdina, what will happen to the equation? Cl2 gas plus H2 gas gives you 2 HCl gas. Correct, Amma? But please make a note of delta H of naught is equal to minus, you have to multiply 92.4 into 2. So we all know that 92.4 into 2 na evlo varudhu? 184.8 kilojoule. So since you multiply the number of coefficient, that number should be multiplied to the delta enthalpy value also. Next one, for a reaction, if you have an enthalpy is going to be a value, for example, you take, if the equation is reversed, magnitude remains same. While the sign convention changes. What do you mean by this? Let me write an equation and explain. So 2H2 gas plus O2 gas gives you 2H2O gas. So the enthalpy of formation of this would be equal to minus 967.4 kilojoule. You reverse it. 2H2O gas gives you 2H2 gas plus O2 gas. Nothing will change. Instead of minus, it will become plus 967.4 kilojoule. Please make a note of all these points, ma. In your textbook, they have given the words. You people should understand the concept and write. Okay. Once you are done, let me know, ma. We will move forward. Enthalpy of reaction. So what do you mean by enthalpy of reaction? So when you say something as enthalpy of reaction, you should have a reactant which gives you a product. Correct, Amma? So you will write enthalpy of reaction is equal to enthalpy, summation of enthalpies of the product minus summation of enthalpies of the reactant. Let us do a problem as given in the textbook. They have done one problem. I will do the evaluate yourself problem. So they have given for an equation CO2 gas plus H2 gas gives CO gas plus H2O gas. So they have given the enthalpies of formation. Write down. Delta F H naught is equal to delta H of nat of values of CO2, CO, H2O are given. What are the values? For CO2 it is minus 393.5. Everything is in kilojoule per mole. This is carbon monoxide minus 111.31 kilojoule, minus 242 kilojoule per mole. So you can see they have given the value for carbon dioxide, carbon monoxide, water, but for hydrogen we have to take it as 0 kilojoule, because for a pure compound we will take like that only. So now write down delta enthalpy of reaction is equal to summation of the product. So what are all the products we have? We have water molecule, that is minus 242 kilojoule plus minus 111.31 grams. So minus of that you have to take the summation of minus 393.5. Do the calculation and tell me what is the delta RH naught of the value, ma? It is minus 242 minus 111.31 plus 393.5. 393.5. Tell me the value of delta H or not, ma? Note down the answer, ma. Delta R H naught is equal to plus 40.19 kilojoule per mole. Calculation you should do, ma. Next time onwards, please make it a practice. Right, let me go to the next part. Right, next enthalpy, it is heat of combustion. What is the next topic, my? Heat of combustion or enthalpy of combustion. It's also called as enthalpy of combustion, delta HC naught. Remember, enthalpy of combustion is something which always be an exothermic reaction, which is always an exothermic reaction. What do you mean by exothermic reaction? Heat is liberated out. For example, you take methane plus 2O2 gas. It gives you carbon dioxide gas plus 2H2O liquid. So the enthalpy of combustion is equal to minus 87.78 kilojoule per mole. Now let me write the definition. Definition is important. It is the amount of heat, I told exothermic, so amount of heat liberated when 1 mole of any substance completely gets burnt in oxygen is called as enthalpy of combustion. So for every molecule, the combustion values will change. It's not going to be the same, it will change. Okay, so with this I am concluding for the day. So in today's session In today's session, let me stop recording.